All right. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Good morning, everyone.
Good morning, sir.
Okay, I hope all of you are sehat walafiat, in good condition, ready to learn something today. All right, now it's already 12 students here. We are still waiting for the other to join in also. So before we start our lesson today, as usual, let's have a prayer first. Pray, begin. Amin. All right, guys, welcome back. This is the 4th week of this semester. We officially finished the first topic, which is about the colligative properties. In this next topic, we are going to learn about new things today, and maybe we will need more time until the end of this semester, not the end. Until the end of this semester, maybe we are going only talking about this topic. It's a very long topic and it's separated into different chapters. It is about electrochemistry. Yeah, it is about electrochemistry. And I inform you in the group that we're not going to have a unit task for colligative properties because colligative properties is not included in the essential topic. So maybe colligative also will not be asked in the midterm. I don't know. We are still discussing with the other teachers because colligative is not included in the essential topic. As we know that during the pandemic, there were changing in the curriculum. School and teachers can decide which topic are essential. And according to the Ministry of Education, colligative properties is not essential. So maybe it can be also not be taught to the student, but no problem. We finished already that topic. It's an extra information for you. Maybe it will be benefit for you if you enter the university, because sometime in the exam they can ask you that kind of colligative properties question also. But in the school, we are still discussing about the colligative properties. That's why in the weekly task, this week we're going to have weekly tasks on Saturday, and this week will be chemistry week, as we know that. I'm not going to ask you about the colligative properties. We are going to have only the topic what we learned in this week, electrochemistry. So in the weekly task, there will be no colligative. There is only the thing that we learn in this week, which is electrochemistry. All right, is it clear? One student are still missing. Anyone knows who is not here? Look at your right, your left. Who is not here? Yogi, are you here, Yogi? I didn't see Yogi. Yogi, right? Yogi is not here. Okay, let's wait for him. Okay, now let's start our new topic. Actually, you're a little bit familiar with this. Before, it was in 10th grade when you are learning with me also. We learned one topic, which is about redox. Do you remember this? Yeah, I told you at that time, we're going to learn more about electrochemistry in 12th graders when we learn about redox. I remember that I say that to the classroom. Now we come to the 12th grader, done, and we're going to continue to learn about the redox. Yeah, we're going to make it more information about thing that related with the redox. And actually, this is under the title of electrochemistry. So we're going to dealing with the electro means electricity is movement of electron. So there will be a movement of electron that we are going to see. Of course, we are not going to see the electricity like you see in the physics, but we are going to see the chemical part of this electricity, which is the electron movement. Yeah, not the current. Yeah, in physics you learn the current. We are learning here in the electron movement. Of course, there will be also some coincide topic, which is the same maybe with the basic. Also, we are going to mention about the current also in the next time, maybe in the next 2 or 3 weeks, we're going to see also that one. But mostly we're going to deal with the movement of electron in electrochemistry, sorry. All right, now let's remember what is redox is. Anyone want to say something? What is redox here?
Reduction and oxidation reaction.
Very good. It is a reduction and oxidation reaction. What is reduction reaction?
Decreasing oxidation number.
Very good. Decreasing oxidation number. When I say like this, ON, it's mean oxidation number, okay? Not on, off, no. ON is oxidation number. How about oxidation?
Increasing.
All right, is the increasing oxidation number. All right. Now, let's remember about this. Oxidation number. What is oxidation number? All right, difficult to answer, right? How to define the oxidation number. Let's write the rules that you know about finding oxidation number.
Free element are 0.
Sorry?
Free element.
Free element?
0. Free element.
Or elemental form, yeah?
Yeah.
Elemental form of something. The oxidation number is equal to
0.
0. Very good. Any other?
The total oxidation number in compound is 0.
All right. Total oxidation number of compound or molecules, yeah, is equal to 0 also. Very good. What else?
The oxidation number of a free element is always 0.
Oxidation number of
Free element.
V? What is V?
Free element.
V. I couldn't get the word here. V.
Free, sir. Free. Bebas.
Free. Oh, you mean free? It is already here. Elemental form means it's free. Free element is elemental form. The same here. Yeah, this free element, it's mean that's elemental form. Okay, what else?
Oxidation number of an ion equal to the number of the charge.
Okay. Okay, oxidation number of ions or polyatomic ions, isn't it? Not only ion or polyatomic ions are equal to its charge. Very good. What else? Oxidation number of oxygen,
-2.
-2.
yes, is always -2, except there's an exception here. Except apa?
Peroxide.
Peroxide. The example of peroxide, H2O2, for example, or Na2O2. At this peroxide, oxidation number will be oxygen.
-1.
Oxidation number of oxygen, 1 or -1?
-1.
Yes. Okay, the second exception, superoxide. Yeah. Example of superoxide is KO2, okay, BO. At this time, oxidation number of oxygen is
-half.
yes. BO is not, yeah. KO2, I said. -half. Very good. What else?
Oxidation number of hydrogen is 1 in compound.
Oxidation number of hydrogen is always +1, except in metal hydride, except in metal hydride, for example, BH3 or LEH. In here, oxidation number of hydrogen is equal to not +1, but it is -1. Very good. What else? Let's see one more time. Group 1A and 2A always have oxidation number equal to +1 and +2.
2.
Very good. All right, this is our rule of finding oxidation number in general. Okay, we learned about this one in 10th grader. Let's do some example about this. Can I clear this? Can I clear the whiteboard? All right. Let's do some example. All right. I have some substance here. For each substance, can you find the oxidation number of chlorine? All right. I have 1, 2, 3, 4, 5, 6 substance here. Right, one student already answered. Let's see. Lutfi, very good. Thank you, Lutfi. Wisnu, we get 6, but your answer is only 5. Yes, good, Wisnu. All right. Yoga, thank you. Wahyu, thank you. Yes, the others. Yes. All right. Gifari, I think you have to calculate again. Sauki, very good. Thank you. Okay, let's see. All right. For the first one here, because this is elemental form, yeah, this is elemental form. So chlorine here have oxidation number 0. Yeah. Open in here we have Na, yeah, Na is +1 because it's 1A group. So totally 0. So Cl must be here -1. Yeah. In the third one here, Na is already also known +1 because Na is 1A group. Oxygen is already known -2. So when you see this one, how to make it 0, the total sum of this compound is 0. So chlorine here obviously must be +1. In here also Na +1, oxygen -2. So to make it 0, we have 2 here. 2 times -2 -4. Here +1 -3. So it must be +3 here. Right? In here, Na +1 again, chlorine -2. 3 times -6 +1 +5. So chlorine must be -5. Chlorine must be +5. And here also the same, Na +1, oxygen -2, 4 times -2, -8, +1, -7. So to make it 0, it must be +7 in here. All right, thank you. Let's do another example. Again, the same, yeah, you're going to find the oxidation number of Mn now. I got MnO2, and then KMnO4 potassium permanganate, and I have MnCl2, okay, and I have Mn2 plus, the charge is 2 plus, and I have MnO4 minus. All right, can you find the oxidation number of Mn? Oh, there are some answers here. All right. Gifari, yes, good. Lutfi, yes. Wahyu, yes. Iki, not all true. Denny, not all true. Alfie, yes. Salki, yes. Most of you did. Very good. Let's calculate here. In here, Mn and O2, we know that oxygen is -2. So Mn will be +2 here. Sorry, +4. Yeah. Here, potassium +1, oxygen -2. 4 times -2 -8 +1 -7. So Mn will be +7 here. Here, Mn and Cl, because Mn are not known, so Cl we are going to accept as -1. Yeah. 2 minus 1 minus 2, so it must be +2 here. Here, Mn have a charge 2 plus, so the oxidation number is +2. MnO4 oxygen -2. 4 times -2 -8. Totally -1, so it must be +7 here, because the total is -1. Now, as you can see here, how to write the charge and oxidation number are different. If you writing the charge, generally the number will be at the beginning. 2 plus, this is the charge. But oxidation number +2, not 2 plus. Plus will be in front of the number. But when you write the charge, generally the plus will be after the number. Okay, that's different, yeah, between the oxidation number and the charge. All right, let's continue another example. I want to drill you with this oxidation number because this is important. Now we are going to find the oxidation number of sulfur in those compounds. All right. All right, one student already answered. Lutfi, yes, thank you. Yogi, we have 5, but your answer is 3. Sauki, the last one is not true. Now, Paul Surya, the last one, I think not true. Alfie, yes, thank you. Mursid, yes, thank you. Wahyu, the last one is not true. Givari, the second one is not true. Vishnu, yes, very good. All right, let's do it together. The sulfur, the first one, this is elemental form, so obviously it will be 0, the oxidation number. In here, hydrogen we know is +1, 2 times +1 +3. So sulfur here, 2 times +1 +2, yeah. So it's -2 here. Here, hydrogen +1, oxygen -2, 4 times -8, 2 times +1 +2 -8 +2 -6. So it must be +6 here. Here oxygen is -2, 4 times -2 -8, totally 2 minus, so it must be +6 here to make it 2 minus. Here Na is +1, oxygen is -2, 4 times -2 -8, 2 times +1 +2, -8 +2 -6. So it must be +6 here, but we have 2 here. It must be then +3 in here. Is it clear? Any question up to here?
Inshallah clear.
All right, let's do one more exercise. All right. Now, can you find the oxidation number of chrome in here? All right. Lutfi, yes. Prayoga, the last one is not true. Daud, yes, thank you. Wahyu, the last one is not true. Alpi, yes, thank you. Wisnu, yes, thank you. Sauki, the last one is not true. Denny, thank you. Right. Yogi, thank you. Okay, let's do it together. In here, we know that chrome and chlorine. Chlorine here is noun. Chrome is not noun, so chlorine will be -1 here. And here, 3 times -1 minus 3, so it must be +3 in here. In here, potassium +1, oxygen -2, 4 times -2 -8, 2 times +1 +2, -8 +2 -6, so it must be +6 here. In here also +1 -2, 7 times -2 -4, -14, sorry, 2 times +2 +2, -14 +2 -12, so it must be +12 here. But we have 2 here, so it must be +6 here, right? In here, now in here we have different thing here. We have what? Polyatomic ion here, SO4. What is the charge of SO4?
-2.
-2. So the oxidation number will be -2, right? The charge is 2-, sorry. SO4, the charge is 2- because it's polyatomic. So the charge will be its oxidation number. So oxidation number of SO4 is -2. 3 times -2 -6 to become 0. It must be +3 here because we have 2 here. So this is the answer. All right. Do you have any question about this? We review about the oxidation number. Actually, this is what we learned in 10th grade. Everything is okay? All right. If everything is okay, the next thing is we are going to balance the redox reaction. Now we are going to deal with the redox reaction. We know that some of the reaction is redox, some of the reaction is not. If there is a reduction and oxidation in the reaction, then it is redox. If there is no reduction and oxidation, then it is not a redox reaction. In redox reaction, you have to balance, and how to balance the redox reaction is not as easy as a normal reaction. Yeah, we need to use different method to balance. Okay, let me write here balancing redox reaction. This is our topic. After we know how to write the oxidation number. For example, now who can balance this reaction normally? With the knowledge that you know from 10th grader how to balance a reaction? I'm writing a reaction. For example, like this. Anyone can balance this reaction? I mean, you will add coefficient in front of the substance to make it balanced. Is it possible to balance this reaction?
No,
Why no?
because in the product side, we have no hydrogen.
Yeah, when you look at the species in the reaction, in the reactant and in the product, somehow is some missing species here. For example, in the reactant we have hydrogen, but in the product there is no hydrogen. So with your knowledge, with a normal balancing method, it seems to be impossible to balance this reaction. But if you are thinking that is a redox reaction, it is possible to balance this. Do you know how? All right, we are going to learn how to balance this reaction by using redox methods in the second hour, inshallah. We have only 1.5 minutes. So in this first hour, we just review what we see from 10th grader is about how to find out the oxidation number, because it's a very basic thing in learning electrochemistry. If you couldn't do this, finding the oxidation number, it's mean that we are going to build a building without a foundation. So the foundation is you have to know how to find out the oxidation number. After that, we are going to see now how to balance the redox reaction. And after that, we're going to see that how the reaction is happening in the cell, yeah, to produce electricity or need electricity. We are going to see that one in the following weeks, yeah, in electrochemistry. All right, I hope all of you are master already how to find the oxidation number. So in the second hour, we are going to see how we are going to balance that reaction that seems to be impossible with the normal method we know. Okay? Very good. All right, everyone is here now. Thank you.